that. Hey, I'm going to try to talk to you today about center mass of a point particle system. So I made a little PowerPoint and let's get to it. I'm going to move my camera there. All right, so why should we care about the center mass? That's the first thing. The short version is we use it all the time in other cases. For example, we worry about the net gravitational force acting on an object that will act at its center of mass. Okay, that's used in these other sections here. When you throw an object, it will rotate about its center of mass. So we use that in two other chapters. The point being this, we're going to use center of mass in a number of different ways for other sections of this course and other courses. So it's pretty darn important. Here's the center mass equation in sigma notation. So if you're not familiar with that notation, I wrote it out another way. Capital N is the total number of masses that you have in a system. And the blue denominator, if you look carefully, could actually be rewritten as the total mass. So let's look at an actual example. So how can we use this center mass equation to do the example that hopefully you can see in the upper right? I've got three masses. What are my assumptions for this? So my grid lines are spaced every 5 centimeters. I've got the masses written there in grams, and the black axes, the black solid lines, will be the x-axis and the y-axis. So a quick question for you. What should be used for the x sub i's? So I'm going to let you pause the video, take your guess. Don't overthink it. Just guess what it should be. Okay, hopefully you had a second to think about it. Remember that the x sub i's represent the positions of these three particles. And notice x1 is 10 centimeters, not 2, because the grid lines are 5 centimeters apart. If that caught you, don't worry, you'll get it next time. Notice that x2 actually has a negative position. Position is a vector. It can take on plus or negative values. If you're thinking back, you might remember that there's an implied I hat on a position, so it's -5 centimeters I hat, but we leave off the I hat just to reduce the clutter. All right, and x3 is a positive number. Just because the y coordinate is positive doesn't mean the x coordinate is, just because the y coordinate is negative doesn't mean the x coordinate suddenly changes. It's a positive x value. So here's our equation. Let's see, how should these things, you could think for a second how these should be plugged in, or if you want, you could literally pause the video, punch them in yourself right now, and verify you can get the same answer I do. Okay, so I'm going to go ahead and move on. So there's the number, and I need to move this out of the way a little bit so you can see. And hopefully you notice that when you plug all that in, we get the grams cancel out. There's grams in the top on every term, grams in the bottom, and the centimeters survive. So whatever units you use for position end up being the units of the center of mass position. All right, so what should you notice about all this? In the work that we just did, we found the center of mass was located right there. Hopefully you see the center of mass in the picture now. And in this case, what if we had taken the average position? The average position would be get the position x1, x2, and x3, add them all up and divide by 3. That is not the same number. So what are you supposed to notice here? The center of mass is not the same thing as average position. The center of mass is where the gravitational force acts on average. The analogy is a class of different exams are worth different amounts, weighted grades. Each exam score is analogous to the position. So the test score 1 would be like x1, and the relative weights in the course are analogous to the different masses. So if you see that in equation form, let me get this out of the way. Sorry about that. The course grade would look something like that, perhaps. And you can see it looks somewhat similar. Just like some exams matter more than others, you have large masses affect the center of mass more than small masses. So hopefully that makes some sense. The final exam matters more to your grade than a midterm sometimes. So just like the big mass matters more than the small mass. That's it.